We'll continue with the topic 1, paper 2, measurements and uncertainty. We reach question number 2. In question number 2, we have a student. He measured the acceleration due to gravity by using two different masses, M1 and M2. M1 is greater than M2, and he used this formula to calculate the acceleration of a free fall. G equals A times M1 plus M2 divided by M1 minus M2. The values for A, he've got 0.200 or 4 positive or negative, 0.002. The first part always is the actual or the measured value or the mean value. Second part, after positive or negative, is the absolute uncertainty part. So this one is absolute uncertainty for acceleration. For mass, the absolute uncertainty for M1 is 1,000th or 0.001. For M2, it's same thing, 1,000th. Now I need to calculate the percentage uncertainty in G. To find the percentage uncertainty or the fractional uncertainty, we can find the fractional uncertainty first and then multiply by 100 the final answer percent to find the percentage uncertainty. We go to the formula. Now the formula, we have A multiplied by all of this, by the ratio between the two masses divided by the difference between the two masses. If I want to find the uncertainty, if I have multiplication or division, always you find the fractional uncertainty and you add fractional uncertainty. So here is the equation will be. So I will have the absolute uncertainty for G divided by G. This will equal the absolute uncertainty for A divided by the original value. This will give me the fractional uncertainty, plus absolute uncertainty for M1 plus M2 divided by the original values or the measured values for M1 plus M2. This will give me fractional uncertainty for the two masses, plus the absolute uncertainty for M1 minus M2 divided by the measured value for M1 minus M2. So this is the fractional uncertainty. All you need to do now is substitute. I don't need to substitute the value of G because I need here to find the percentage uncertainty. So I will keep delta G over G as it is because this number as a whole will give me the fractional uncertainty. And this will equal delta A is 0.002 divided by A is 0.204 plus absolute uncertainty for M1 plus M2. Absolute, if you have addition or subtraction, always you add the absolute uncertainty. So absolute uncertainty for M1 plus M2, I'll go to the uncertainty, the absolute uncertainty here, it's 0.001 or 1,000th plus 0.001 for M2, I'll take the values, divided by the measured value or the mean values. For M1, I have 0.125 plus 0.12 plus for subtraction, again, as well add absolute uncertainty. Never subtract in the uncertainty, always add. So I will go and add the absolute uncertainty, same thing, is 0.001 plus 0.001 divided by M1 0.125 minus M2 0.12. Now let's find these values now. The first one, it's 9.8 times 10 to the power -3 plus 8.16 times 10 to the power -3 plus 0.4. plus 0.4, and you should get 0.418. Percentage uncertainty, just multiply this number by 100. So when I multiply by 100, I should get 41.8%, which is around 42%. This is the fractional uncertainty in free fall acceleration. The other part of the question, he wants me to find the absolute uncertainty. So I'll take this value here, I will keep it, okay? I need to find the value of G, substitute here in this equation, and find the absolute. Let's do it together. I need to erase all of these first. So we have delta G over G, this is the fractional uncertainty, will equal 0.418. I need to find G first from this equation. The value for A, the acceleration, is 0.204 times M1. M1, it's 0.125 plus M2. M2 is 0.12 divided by M1 minus M2, M1 0.125 minus 0.12, and this value, it's 9.996 meter per second square. So I need to substitute now here in this formula. So delta G divided by the mean or the calculated value of G, which is 9.996. This will give me 0.418. Cross multiplication, and you should get the absolute uncertainty. This will give me the absolute uncertainty in G. So the absolute uncertainty will be 9.996 times 0.418, and this will give me 4.2 meter per second squared. So the final answer for G, when I write the final answer, you write the mean value or the actual value, positive or negative, the absolute uncertainty, and this will give me 9.996. You can round it to 10. Positive or negative, 4.2 meter per second squared. That's it. See you inshallah in the next video. Next question.